Hello. Now we are going to learn the third application of differentiation, which is rate of change. Okay, if y is the function of x and x is the function of time t, then y can be expressed as a function of t by using the chain rule. Okay, chain rule. Actually, we have used chain rule previously when we want to use power rule to differentiate composite function. Do you still remember? Okay. So given the chain rule, for example, here we have dy dt equals to dy dx times dx dt. The negative rate of change is called rate of decreases. Okay, here for example, if we have A is area. Okay, so rate of area is dA dt. Okay, rate over dt. For example, we have V is volume. Okay, rate of volume equals to dV dt. Okay, let's say we have P is, let's say, profit. So rate of profit is dP dt. So whatever rate we is actually over dt. Okay, here to apply the chain rule. Okay, for example, if we have dv dt. Okay, so dv dt actually dv d whatever times whatever dt. Okay, so this numerator must be same with this this denominator. This denominator must be same with this numerator. Okay, it could be dv dx times dx dt. Okay, same. Same. We have both over dx. Okay. Okay, let's say it could be maybe dv dt, it could be dv dr, okay, times dr dt. Okay, these two must be same. Okay, so this is, we call it this chain rule. Okay. Okay, now we are going to do example here. Given radius r centimeter of a circle, okay, is increasing at the rate 0.5 centimeter per second. Okay, the clue is circle. Okay, and we have r rate. Just now I told you the rate is actually over dt. So rate of radius is dr dt equals to 0.5. Okay, so then here given the clue is circle. Okay, so find the rate of increases of the area. Okay, area. So area of circle actually, what is formula area of circle? Okay, pi r squared. Okay, so now we have a in terms of r. Okay, so we differentiate, we get dA dr. Okay, equals to 2 pi r. Okay, so now given the value of r is 10 centimeter, so we just substitute r is 10, 2 pi times 10. So dA dr is 20 pi. Okay, so the question asks you to find the rate of increases of area. Okay, rate area. Okay, so just now if rate over dt, so then dA dt equals to dA whatever times whatever dt. Okay, so now we can refer that we already have dA dr, okay, and dr dt. So therefore here we fill as dr. Okay. Okay, so then we just substitute dA dr. Actually this one 20 pi and dr dt, this one 0.5. Okay, so we this one 20 pi times 0.5. This one equals to 10 pi. Okay, next question number 2. A hemispherical bowl contains water of depth x centimeter. The volume of the water is given by V equals to pi in the bracket 6x squared minus x cubed over 3 centimeter squared. Okay, if the water flows out, okay, given the water flows out, means decreasing, okay, at the rate. Okay, now we have rate, okay, the word of rate. Okay, and we can see here the unit is centimeter cube per second. So therefore actually this one dv dt, okay, equals to negative because decreasing, okay, negative 20. Okay, now you have to find the rate of decrease of the water level. Okay, now again we find the word rate. Okay, water level. Just now, water level is x. Okay, so meaning that you have to find the dx dt. Okay, rate over dt. Okay, so dx dt, okay, equals to whatever. Okay, so now before we answer this question, you have to create the chain rule. Okay, so if to create the chain rule, you must have 3 expression. Now we only have 2. Okay, the first one dv dt, this one dx dt. So we have from this question given v. Okay, v equals to, we expand pi. Okay, 6 pi x squared minus pi x cubed over 3. Okay, so now we have v in terms of x. So then we differentiate, we get dv dx. Okay, so dv dx, okay, become 12 pi x minus 3 pi x squared over 3. Okay, so this one dv dx equals to 12 pi x minus pi x squared. Okay, so now given x is 5, so we substitute into dv dx. So 12 pi times 5 minus pi 5 squared. This one 60 minus 25 is 35 pi. Okay, so dv dx is 25 pi. Okay, so now look here. We have dv dt. Okay, we are going to find dx dt, and here we have dv dx. So we create the chain rule. Okay, we create the chain rule. The subject is the value that we are going to find. Okay, so dx dt equals to dx whatever times whatever dt. Okay, here the clue is dv dx. This one we choose as dx dv. This one must be same. Okay. Okay, so now you have dv dx. Okay, now you want to substitute dx dv. So 1 over, okay? So 1 over 25 pi. Okay, times dv dt just now from the question is negative 20. Okay, negative 20. So this one we simplify. We get... wait a minute, 25. This one 35. This one 35, okay? So this one 35. Okay, so negative 20 divided by 35 is negative 4 over 7 pi. Let's do another example here. Question number 3. Okay, an open cylinder has a height of 20 centimeter and radius of r centimeter. Okay, so we have open cylinder. We draw open cylinder. Okay, height is fixed, which is 20. and the radius is r. Okay, so find the rate. Okay, here the clue is rate area. Okay, meaning that dA dt. Okay, fine. Okay, question mark. So then here we have rate radius. So dr dt equals to 0.4. Okay, when the radius is 5 centimeter. Okay, now the clue is area of open cylinder. Okay, so we have to find the area of open cylinder. The bottom one is a circle. So area of circle is pi r squared. Okay, plus the curve surface is 2 pi r h. Okay, since of h is fixed, so we can substitute early. Okay, so RH is 20. So pi r squared plus 40 pi r. Okay, so we have A in terms of r. We differentiate, we get dA dr. 2 pi r plus 40 pi. And we can substitute the value of r just now, 5 centimeter. Okay, so 2 pi times 5 plus 40 pi, 10 plus 40, 50 pi. So dA dr is 50 pi. Okay, so now we are going to find dA dt. So we have to create chain rule. Okay, so dA dt, dr dt, dA dr. Okay. dA dt equals to dA whatever, okay, times whatever dt. Okay, now we have clue. This one is dr. Okay, over dr. Dr. Okay, so then this one is dr. This one dr as well. So dA dr we substitute. The value is 50 pi. So dr dt is 0.4. Okay, so 0.4. So the final answer is 20 pi.